minus 4. In the context of our calculus class, there are only two types of differential equations that we know how to solve. It's either separable, or it's first order linear, or it's both. So looking at this, for me, first order linear is the easier one to see. It's first order because I have just a first derivative, not a second derivative. That y, the variable on top, that's the one that I should be looking at everywhere else in the question. And if everywhere else y is raised to the first power, that's going to make it linear. And I can tell right here that that's the case. This is linear. So this is first order linear, and we can definitely treat the problem like that. If I'm looking at this as first order linear, I have to write it exactly in our standard form. So I would need to rearrange this to look like y prime plus something times y is equal to something, where this part over here we call p, and this part over here we call q, so that we can find our integrating factor and solve the differential equation. But if we pause for a second, I think this is also separable. And to see that it's separable, we'd be hoping that we could make this side look like one term with x's times a term with y's. And I'm looking at this and thinking that if we factor by grouping, so if I group that x, y, and that 4x together, then from these two terms, I can factor an x out. So that would look like x times y plus 4. Now, if I again think about factoring by grouping and I look at my two remaining factors, then the negative y and the negative 4, what they have in common is a negative 1. So I can pull that negative 1 out, and then I would be left with y plus 4. So at this point, I can factor that to be x minus 1 times y plus 4. And I would rather solve this as separable, just because I think in general separable, it's fewer steps if we can see how to factor it. So from here, I'd want to divide my y plus 4 term over and multiply that dx to the right. So I'd end up with 1 over y plus 4 dy is equal to x minus 1 dx. Both of those are ready to go for me to integrate. The integral of 1 over y plus 4, going to get natural log, absolute value of y plus 4. And on this side, I'm looking at x squared over 2 minus x plus a constant. If we needed to solve for y, we could raise both sides as e to some stuff, and then finally subtract that 4. So I'm going to sort of do that in all at once, and I'm going to say y is equal to e to all of that stuff, x squared over 2 minus x plus c, and then subtract the 4. And we could go back and use our trick from a while ago, that plus c I can really turn into multiplication in front of the e, and that would be fine also.